Hello again. So I did notice that many of you had a trouble with questions 9, 10, 11, and 12 on the practice paper. You absolutely have a right to have trouble with those. Those are fairly difficult. So what I did many times is I return your assignment, but please, after you do this practice, if you want to come back and turn it back into me, ask more questions, you can always get a full credit. So I think the ones that do give us most trouble are those where you have a sequence or possibly recursive formula. And I think the most difficult part is to figure out the explicit formula. First of all, just so we don't get them confused, the recursive formula is the one where we will have the first term given and we will write our formula in terms of the or we will find the next term in terms of the previous term. The explicit formula is the formula where we are finding, where we have the n given. So let's say I want to figure out what is the third term. I'm going to plug in 3 in here and I can find any term that I want. So as I said, well, let's do maybe this question. And let's start with the recursive formula because this one is a little bit easier. So I'm going to list my first term, and I see that the first term is equivalent to 7. And what I do want to first find is I want to figure out what the pattern is. And then I want to see how can I make this pattern to be a general formula. So I see that to go from 7 to 21, I am multiplying by 3. I see that to go from 21 to 63, again, I am multiplying by 3. And I am assuming that this is the same pattern. So how am I going to put this into the formula? Well, my AN is going to be equivalent to AN minus 1. So I am going to always take the previous term and I am going to multiply it by 3. That's it. Now, again, finding the explicit formula is a little bit more difficult. So because there's a multiplication, maybe you remember something about geometric series. So let's see how I can write the general formula for this. So first of all, I see that 7 is involved in this as well. I do see that 21 is equivalent to 7 times 3. 63 is equivalent to 7 times 9. And 189, I am not sure what that is. So let's see. 7, we could say that this is 7 times 3 to the power of 0. 7 times 3 to the power of 1. 7 times 3 to the power of 2. Now, this is always a question, and you might have seen it in the notes. Sometimes we will have our n to be greater than or equal to 1, or sometimes we can decide that we are going to work with the n's greater than or equal to 2. So for example, for this one, see how nicely this is going to work, where if I take 21 to be my first one, then I will be able to write my formula as 7 times 3 to the power of n, because 21 is going to be equivalent to 7 times 3. So if I take this as my first term, I am going to get that. 63 would be 7 times 3 to the power of 2, because that would be considered to be your second term. Now, if somebody wouldn't think about that, of course there's a different way of writing this. You could say that AN is equivalent to 7 times 3 to the power of n minus 1. And then you would have to write that n is greater than or equal to 1. So this is one way or another, but I want you to see both because, well, they are both commonly used. All right, let's solve another one. And another one that I want to do would be question, this one that is missing a number and I don't know what it is supposed to be. Well, let's assume that it is going to be 2. So if the first term is 2, my recursive formula is going to find the next term and the next term and the next term. So to find the second term, I am going to have 4 times the previous term, so 4 times 2 is 8, and that's it. So I have 2, 8. Then I am going to take 4 times 8, that's 32. Then I am going to take 4 times 32, that is 64 times 128. And then this pattern would keep going. All right, now let's see again what is going to be my explicit formula for this one. Let's take a look at the pattern. Well, I see that this is multiplied by 4. I see that this is multiplied by 4. I see that this is multiplied by 4. However, is there a better way to describe the 8? Maybe somehow in terms of the 2, maybe somehow in terms of the exponent. Well, let's see what we can do here. Excuse me. So if I want to figure out my nth term, 8 is 2 to the power of 3. 32 is 2 to the power of 5. 128 is, well, you guys calculate that one. So can I figure out what is my formula for this one? So I see that it has something to do with 2s. I see it has something to do with 4s, but I really, from what I wrote, I cannot see the pattern. And I want you to see how I struggle with this as well. But now I see something else that I haven't seen a second ago. 8 can be written as 2 times 4. This can be written as 2 times 16, which is 4 to the power of 2. This can be written as 2 times 4 to the power of I don't know what. So let's see. Can I now write this as 2 times 4 to the power of n? But this would not work for my first term, so I would again set for n's greater than or equal to 2. Now, I am not positive if I did this correctly, so what I am going to do is I am going to check. If I plug in n is equal to 2, that is going to be 16. 16 times 2 is going to be equivalent to 32, that's fine. If I plug in 3, 4 times 4 is 16 times 4 is 64 times 2, that is correct. And now I am questioning, did I have to say greater than or equal to 2? What would happen if I say 1? Well, if that was 1, 4 to the power of 1 is 4 times 2. I could have said greater than or equal to 1. And that was probably the intention right here as well. So as you see, those questions, it's not that you get the answer right away. You need to think of the pattern. You need to spend some good quality time with those questions. Let's see. If I did another one, I probably would have chosen this one. And then I am going to leave you with the rest of them. So the first term is 3. The second term is going to be 3 minus 1, which is 2. The next one is going to be 2 minus 1 is 1. And this is just going to go down. I am just looking at this and making sure that this is correct. So my first term is 3, then I am taking the this number, taking away the 1, so that's 2, and so on. All right, so now how would our explicit formula work? Well, my AN is equivalent to, let's see, if I want to figure out what is happening with my numbers, I have to say if this is my first number, this is my second number, this is my third number, and so on. How do they relate to each other? So let's see. Maybe you guys can think of this one. What would I have to do to find the general formula for this one? I think you should be able to figure this one out. If not, I can give you a hint a little bit later. All right, so this one and this one is fine, this one is fine, this one is going to be interesting. Well, this one is going to be tricky. Well, let me do this one and then you will have a good idea on how to finish the one that I haven't done. So this one, the starting number is 15. The next one is going to be 14. The next one is going to be 13. The next one is going to be 12, and so on. So we see that we are just taking away one number. Now again, how am I going to write this as an explicit formula? How do I write something as simple as taking away one number? Well, let's see. I am thinking about taking my negative n and adding 16. Why? Because if this is my first number, so if n is equal to 1, and I turn this to be negative 1 and add 16, then I will get 15 as an answer. If this is my second number, it's going to be negative 2, and then I'm going to add 16, and I am going to get the number that I have. All right, so now having said that, you should be able to finish this one. All right, I just gave you a big hint. So your assignment is to do question 1. I did question 2. 3 is done. 4. Finish 5. And finish 6. All right, another one that gave you a little bit of trouble was to write each series using the sigma notation and take a look. The lower bound is given. I am going to do one of them. This one seems the most difficult, so I want you to pay attention to this. I am starting at 4, that is my lower bound, and what I am calculating is I am calculating how many terms do I have. So 1, 2, 3, 4, 5, 6. And now how do I figure out what is the regularity here? Because those are fractions and I can't just put them together. I need to write them in terms of n. So I want you to see what is happening here. This is 5 times 4. This is 5 times 5. This is 5 times 6. And what I do know is I do know that my n is equal to 4. So, so having said that, what do I do? What do I multiply the term by? So I am taking a fraction that is always 1 over, and I am going to multiply 5 times n. Why is that? Because this is my n, right? Now this is n plus 1. So n plus 1, as n was 4, then this one is n plus 1, that's 5. This one is n plus 2, and so on. And here we go, we are done with this one. Then the next one, the only thing is I am going to give you one hint, and my hint is going to be, take a look, how can we write each one of those numbers in a similar way? So this is 2 to the power of 3. This is 3 to the power of 3. This is 4 to the power of 3, and so on. And this is 10 to the power of 3. So let's see. I am starting at 2, and I am going to have how many terms count them all, and then how are you going to write them as the formula. Finish one or start one and finish three. So that is going to be your additional assignment for tomorrow. And again, if you want to redo any of those questions that you had trouble with before, you can turn them in for the full credit.